Today we'll take a look at some common object-oriented programming concepts, specifically what are sometimes described as the three pillars of OOP, that is encapsulation, inheritance, and polymorphism. So let's start with encapsulation. Encapsulation allows us to build abstractions by hiding details. This makes it easier to modify the code behind the abstraction without breaking other parts of an application. We only expose what others need to get their work done, and we shield them from some of the low-level implementation details which aren't important. That reduces complexity of our code, and it keeps things loosely coupled. And by simply taking the time to create the abstraction, this forces us to think about what exactly a caller of this class would need as a minimum for the class to be useful. And we therefore hide everything else. Let's take a look at the code. Let's take a look at what we're going to start with here. And this code, if you look at it, it's really pretty hard to know what's going on. There are no abstractions here. Lots of .NET framework types. The code is creating a bunch of lists. Then it loads in data from a file and loops through all the lines, and it parses data here. But there really aren't any abstractions. We don't really know what's going on. It's very procedural, which in and of itself isn't bad. However, the business logic doesn't reveal itself to us. It should be clear when we look at it kind of what's going on. The code here creates lists to hold the data. It loads the data, parses it, and then writes out certain employee records which meet the criteria, and the criteria is if age is greater than or equal to 21. So it would be great if we could see the business logic, say something that clearly showed what part of the program was doing the loading, what part was parsing, and what part was outputting the data. So now before we talk too much about applying these OOP concepts to this app, let's talk a little about a couple principles I want to bring up here. One is the Yagni principle, and the other is the KISS principle, and how they might apply here. Yagni stands for you ain't gonna need it. It is a principle of extreme programming, also known as XP programming, that states that a programmer should not add functionality until it's deemed necessary. Secondly, KISS is an acronym for Keep It Simple Stupid, and is a design principle noted by the U.S. Navy in 1960. The KISS principle states that most systems work best if they are kept simple rather than made complicated. Therefore, simplicity should be a key goal in design, and unnecessary complexity should be avoided. So, having just mentioned these principles, I'm going to do just the opposite of this and take a fairly simple application, the one we have here, and greatly increase its complexity, which would seem to go against these two principles. And I suppose it could be argued that the procedural implementation we've just seen here, if it was known that this was a one-off piece of code and would likely be thrown away after use, well then in that case perhaps the work we're going to embark on would be overkill. However, what happens with many applications is that they are modified and they evolve over time, and so what I'm showing today is an example of setting up a foundation for an application that you know will be used and improved, so it's worth putting in the effort up front to create something which can easily be extended in the future. So let's go ahead and take a look at iteration 1, calling this sum OOP. So we have a class, an employee analyzer. I say this kind of loosely. I use the term sum OOP loosely because we haven't done much here. Basically, all we did is to break up the procedural code into methods, which are defined on this class, which we're calling employee analyzer. But we now have a constructor. That's an improvement, which we can use to pass in our file name dependency. So remember that in general, when building flexible software, we want to have dependencies point in and not out. So here's an example where we're passing in this file name dependency into our constructor, and we'll control that at the higher level. We'll be injecting this dependency here, which is a good thing. let's see. Next we have a method which has the single responsibility of loading the employee data from a file. Then we have a method which has the responsibility of analyzing the employees and finding which ones are adults. And then it's going to print to the console here those that it does find that are over 21. Okay, so you can see that we're starting to define roles and responsibilities here. And when we talk about roles and responsibilities, it's good to think in terms of these three concepts: knowing, deciding, and doing. When we define our code in this way, it goes a long way toward creating code that's loosely coupled, flexible, and easily understood. Okay, so let's go down and look at our main method here. There is a higher level of abstraction. I mean, you can see this right here. We new up an employee analyzer class, and we pass in that file name to the constructor that's coming into the program here via our args parameter. Then we call a method on the employee analyzer here called load employees to load our employee records. And finally, we call another method to analyze the employee records. Now, we could in the future use this same basic foundation to traverse through the employees and do any type of analysis we want, and we're all set up for that. So this abstraction we have makes it easier to use this code because we don't need to know all that much about it to use the classes that we've defined here, and we can more easily see at a glance what's going on. We can tell what's happening here. So we've got an improvement here. But we can improve on this. This is really only scratching the surface of what we can do. So let's move over to the final version, which I have here. I'm calling it a OP. And we'll go all the way to the top and start talking about the employee class. So we have an employee class which knows about employees, and we've added a method here which can tell us whether an employee is an adult. Just going to look and see whether the age is greater than 21. Next we have an iData loader interface. Now before we go any further, let's talk about inheritance. Inheritance is good in that it allows us to reuse code. However, inheritance tightly binds two classes together, which makes the code more brittle. And in C#, since it only supports singular inheritance, so once you've selected a base class, that's the only one you'll be able to use. So here I felt that an interface was the best choice. So for this application I created an iData loader interface, which simply defines a single method which needs to be implemented, and that method is load data. See it right here. And since it's an interface, the class that's going to implement this interface will supply its own implementation. So you see we have the file loader implementation here, which was what basically we did in the previous version. We loaded through a file. Let's see, by utilizing an interface here, it was easy to go ahead and create the web loader class, which also inherited from, implemented the iData loader interface. And later we'll see that this lets us use polymorphism to load using the correct method at runtime. So that made things easier. Let's go on down to iEmployee Parser. Next, I've created an iEmployee Parser interface. We are currently just using a CSV file, and due to time constraints, I won't have time to implement any other parser types. But by using an interface here, we've set ourselves up, and we have the option of later creating, say, an XML, employee XML parser, for instance, which would parse data from an XML file, for instance, without breaking our code. So we've gone ahead and set that up. Let's go on down now and talk about, well, briefly while I'm here, let's talk about the employee CSV parser class, which implements iEmployee Parser. And you'll see, we've got this one method, parse employees, which returns an I list of employee. And what we're doing here is we're passing in the loader, which we're going to define at a higher level. We're injecting that dependency here. This particular parser class knows nothing about how its data was loaded, but it's able to call loader.loadData. And then we've got a little bit of link here that's going to pull our data out, and it's going to select it into employee records and then return our iList of employee. So let's now go on down and we'll look at our main. Okay, here we are. So here's our main application code. We have a static method that we're calling here Getloader for. We're going to call Getloader for. We're going to pass in the arguments, which in this case is just file name. And it could be file name or URL. And in our case, we're using a file name. But our static method here, Getloader for, is going to be past the source, and then it's going to look to see whether HTTP is in that source string. If it is, it'll instantiate a web loader and return that as the iData loader. If not, it'll instantiate a file loader and return that as an iData loader. Okay, so let's go and look what we're doing here. Yeah, so this code is pretty easy to understand. You can see we're calling Getloader for. We're getting our loader. We're newing up an instance of employee CSV parser, passing in the loader that we received, and then we're newing up an employee analyzer, and we're calling analyzer.findAdults, and then we're iterating through the returned collection of adults and printing each adult employee. So now let's go up and take a look at what's happening in Employer Analyzer class. Here we are past the parser to use in the constructor. We save that. And then we call parser.parseEmployees. Here's another situation where polymorphism would come into play, assuming that we had gone ahead and created, say, an employee XML parser. The employee analyzer class would be passed a parser class instance, which implements the iEmployee parser interface. And through polymorphism, the correct parseEmployees method would be called based on the CLR dynamically determining the base class type and calling the correct method on the fly at runtime. So we'd have another situation here where polymorphism would come into play, and we could have as many different employee parse methods as we want. So that's good. Let's go on. So then we parse the employee data, and we now have a list of an iList of employees. Sorry, let's go up here. So the next thing we're doing is we're going to look at this adult locator class. So the adult locator gets past the employees that we've been able to load in and from our parser, and we'll go up and look at that. Here we iterate through the employees, and we call yield return on any employee we find that is in fact an adult. This builds up our list of adult employees by adding them to our IEnumerable of employee, which we are returning. So I think you can see that we've achieved the goal of having small abstractions that can be composed to accomplish the task at hand. And I think these abstractions are also more likely to be reused in future applications. So that's about it. In summary, we've covered the three pillars of OOP: encapsulation, inheritance, and polymorphism. We've showed how modern OOP favors interfaces and delegation to achieve code sharing. I skipped over a step of using, we could have shown using abstract classes, but I went right to the interfaces to get the inheritance we needed, mainly because interfaces just gave us the flexibility we wanted here when it came to having complete flexibility with loading and parsing. And it made things more flexible and less brittle in general, so I went directly to that. We ended up using a technique called delegation to achieve code reuse. With delegation, we gain the benefits of inheritance without the downsides. So I hope this screencast helped in understanding some of these important OOP concepts. In the next screencast, we'll look at functional programming and what that approach entails. Thanks for watching. Bye for now.